Today we're going to talk about zeros and multiplicity of polynomial functions. Okay, so let's talk about what a zero is. So zeros, or roots, they're also called roots, they're just x-intercepts. X-intercepts. So anywhere that the curve or the line goes through the x-axis could be called a zero or a root. Okay, the way to know how many possible zeros you can have will be from the degree. So the degree of your function tells you how many zeros you could have. Well, it tells you how many real zeros anyways. No, it doesn't tell you the real zeros. It tells you how many zeros. Roots the function has. Now, what we're going to look at today are real zeros, but the number of zeros is actually determined by the degree. So, for example, let's say I had y equals x to the fourth. This actually happens to be degree 4 because its highest exponent is 4. So this would be degree 4, and it would have 4 zeros or 4 roots, okay? If you had something like y equals 3 x to the 6 plus 5 x squared plus 7, the degree of this polynomial is the largest exponent, so that largest exponent is 6. So this one would have a degree of 6, and this would also have 6 zeros. Now here's the thing about the zeros. What we're going to look for, you can have real zeros or you can have complex zeros. Today we're going to look at real zeros, and we're going to do that by graphing. So one of the ways to find the zeros is by graphing, okay? So let's look at graphing to find zeros. Now, this is only good for finding real zeros. You can't have imaginary zeros. This is only good for finding real zeros. Okay, so let's say example 1. Let's say you have f of x equals x to the third plus x squared minus 2x. And what you would do is you would just graph that. So, and let me show you real quick how that would look. So let's, I don't know if I can pull up my Desmos. Oh, I can. There we go. So let's go ahead and graph that. So x to the third, to the third, plus x squared minus 2x. And right here, where it goes through the x-axis, those are the zeros. So notice it's where the y value is 0. That's where the zeros are. It's where the function is equal to 0. So it'd be -2, 0, and 1. So our zeros would be at the points -2, 0, 0, 0, and 1, 0. And you know what? Let's go ahead and graph that just for our notes so that we have a sketch of what that graph looked like. So it started at the bottom, right? It came through and kind of went like this up to the top. Now this should not be unusual. We know that the direction of that curve is going to be determined by the leading coefficient. So this leading coefficient was a positive 1. So just like the parent function for cubic, it should start low and end high, and this one does. All right, now notice they're called the zeros. They're called the zeros because this is where the y is 0. Everywhere the y is 0, that's where you're going to have an x-intercept. So we call those zeros -2, 0, and 1. So we would say x is equal to -2, 0, and 1. That's where your zeros are. And that's how you do that by graphing. You just look at it. You find where it goes through the x-axis. Also, one more thing. Notice that there are 3 zeros in this case. That is not unusual. There are 3 x-intercepts, right? One here, and one here. That's happening because we have an exponent of 3. So that's why that's possible to have 3 x-intercepts. okay, because of that, because the degree is 3. Okay, let's look at another example. Example 2. So let's look at f of x equals, and these are all functions, so we can use f of x. F of x equals negative x to the 4 plus 4x to the 3rd minus 2x squared minus 4x plus 3. All right, so let's look at the graph of this, and I'm going to put that in Desmos just for speed. So I have negative x to the 4 plus 4x to the 3rd. Oops, it helps if you write plus. Minus 2x squared minus 4x plus 3. There you are. Now this one, you can see where the x-intercepts are. They're right here. Okay. This one can be a little bit confusing because you may be saying to yourself, this is degree 4, and there's only 3 zeros. That is correct. And we will talk about that shortly, why that happened. Okay, so let's go ahead and get this graph sketched out. So we had a 0 at negative 1, 1, and 3. So our zeros were at negative 1, 0, 1, 0, and 3, 0. And let's sketch out what that graph looked like. So here's my x and y axis. And let's see, it kind of comes up like this, and then it comes and bounces off here, and then it comes back down. Now, it's not shocking that this starts at the bottom and also ends at the bottom. We knew that was going to happen because this has an even degree right here, and because it starts with a negative. So it starts with a negative, so it should be down, down, starting down, ending down. That should have happened. What's going to happen though? So here's a 0, here's a 0, and here's a 0. This actually does have 4 zeros. Technically, one of the zeros is listed twice. And that's what happens right here. So do you see how the line comes down to this blue point and then bounces right back off of it? That's because what you have is a double root, meaning that number counts 2 times. So we have this root at negative 1, this one at 1, and this one at 3. And the way you would see that mathematically is you'll see negative 1, 1, 1, and 3. So technically there are 4 of them. However, we don't write repeats when we're writing solutions. So the actual solution would be without the repeat. So negative 1, 1, and 3. So just so you know, this is degree 4. There are 4 roots. We just don't write the repeats. Now there is a way to find this without graphing, and you can do that using factoring. Okay, so let's look at that. So let's find the zeros with factoring. All right, so let's find the zeros with factoring. So let's say we have, let's see, f of x equals x to the 3rd minus 2x squared minus 15x. Well, the first thing I'm going to do, I'm going to set this equal to 0, okay? Because remember, the x-intercept is where y is equal to 0. So if I set y equal to 0, I'm already trying to find those x-intercepts. X-intercepts are zeros. Then I'm going to factor this. So it's set equal to 0, I'm ready to factor. I notice that there's a greatest common factor, so I'm going to pull that one out first. So the greatest common factor is x. Then after I pulled out that greatest common factor, I can go ahead and factor this trinomial. So to factor this trinomial, see, that would be x. I want to do minus 5. X minus 5, x plus 3. Yeah, that would absolutely work. So x minus 5, x plus 3. Now that it's factored, I can set each factor equal to 0 using zero product property. X equals 0, or x minus 5 equals 0, or x plus 3 is equal to 0. And here are my solutions. I have one right here, x equals 0, Or x equals 5. You could solve for x. Again, I'm going to solve for x. X equals -3. And those are my solutions. So x equals -3, 0, and 5. That's where the zeros are going to be. That's where the x-intercepts are going to be. I'm not surprised that I have 3 of them. The degree was 3. I should have had 3 solutions. Let's do one more of those just for clarity. Let's do one more. So let's see. Maybe I have, let's see, one more. Example 4. Let's find the zeros using factoring, okay? So let's do f of x equals x to the third minus 6x squared plus 9x. Okay? Yes, that will do what I want. Okay, so I'm going to go ahead and set this equal to 0 so I can solve that. Well, I should have talked about multiplicity. I'll do it in a minute. Here we go. Set equal to 0, then I'm going to go ahead and factor. I notice that there's a greatest common factor of x, so I'm going to go ahead and factor out the x. Then I have a trinomial here. I need to go ahead and factor that trinomial. I want to use 3 and 3, -3, -3. All right, so that, when I set this up to find my zeros, right? So technically we have here x equals 0, or x minus 3 equals 0, or x minus 3 equals 0. All right? This is a solution. If I solve this for x, I end up with x equals 3 and x equals 3. Notice that this same solution came twice. I needed it to be there twice because remember, this has a multiplicity of 3. This is a degree 3. So that means there should be 1, 2, 3 zeros, even though these 2 zeros were listed twice. So the way you would list the zeros for this is you would say x equals 0 or 3, and that's what you would say, but the reason that happened is because there's a multiplicity of 2. So we would say that that happened because x equals 3 has a multiplicity of 2, meaning x equals 3 happens 2 different times. And if you graph it, there should be a bounce right here at this multiplicity. Anytime you have an even multiplicity, you're going to have a bounce. So if you graph this, and we could do that, x to the third minus 6x squared plus x. X to the third minus 6x squared minus 9x. Maybe that wasn't right. Plus 9x, haha. There we go. And now you can see that. So there's a cross through, the line crosses through the x-axis at 0, 0. And then there's a bounce right here at 3, 0 because that had a multiplicity of 2, so it made the graph bounce. And so that's how you find the zeros and the multiplicity of the zeros for a polynomial function.